All right, welcome back. Keep going with more free response questions today. Got a bit of a hard one from 2011. So objectives are to create expressions for work and average force done by a ballistic projectile on an object, and then use work energy theorem to create expressions for the distance that the projectile travels after hitting the object, which would look like this. Okay, so we've got our projectile that we're launching from this device. Given its impulse, JP, and average force, I want to express the time required for the projectile to travel the length of the launching device in terms of the velocity, impulse, and average force. And then any fundamental constants. What do we have to do? Okay, so what do I have to do for part A? Okay, we can write in start with impulse, that's good. So our impulse is equal to what? Integration of force. Force in terms of what? Okay. Well, it's the integral of the force in terms of time from 0 to t. And the problem is we don't have that integral, but we can estimate it with the average force. So we could say our impulse is equal to what? Okay, you're not wrong, but we want to solve for time, so I'm going to leave it like this since we've got a time in our equation right now. But when I integrate, what's going to happen? Okay, we could say what we're really doing with this integral is I'm multiplying force times time. So this is my average force times time. Even more specific, this is my change in time. Even more specific. Okay, so that if I want to solve for time, what do I have to do? Okay, so impulse divided by average force should give me the time. Okay, that's good for A. Then for B, we need to determine an expression for the mass of the projectile. Okay, and this is closer to what you were just saying earlier. I think you were trying to use momentum. So our impulse is our change in momentum. So that means our impulse is mdv. Right. Okay, what's my change in v? Okay, what's my v final right now if we're looking at the end of the launching device? Vx, and what's my v initial? 0. So we started at rest, and then we ended up getting to a velocity of whatever it launched from the launcher at. So that means our impulse is equal to mvx, and therefore my mass is equal to our impulse divided by vx. Okay, so there's A and B. Any questions on A or B? Okay. Then I need an expression for the work done in stopping a projectile if we fire horizontally into a block of wood that is clamped to a tabletop, so the block doesn't move. The projectile will travel a distance d into the block before it stops. So, block, projectile, we're going to travel a distance d into the block until it stops. Okay, so I need an expression for work. What do I have to do? Okay. So work is a change in energy. Change. Okay, work is my change in kinetic energy then. So my work is, what's my final kinetic? Okay. And then the rest of this will be 1/2 mv squared. Um, we did find the mass in B, so we can substitute. And that V is Vx, since the projectile is moving horizontally. So there's no gravity that's pulling us horizontally, so that's going to stay the same. Okay, so then we can substitute for m, which we found last time was j over Vx, right? Okay, times Vx squared. Okay, and then we just simplify and we're done. That works. So minus, I'm going to rewrite this, I think, just to make that fraction bigger. Minus jvx over 2. I'm also going to move that negative up. Just because if I don't, sometimes it looks like it's part of this fraction and might not get full credit for it. Okay. And that should be good. Okay, that's part C. Then part D. Do I have an expression for the average force on the projectile as it comes to rest in the block? Okay, so we said earlier, this was, we didn't actually, because this is work, not impulse. Okay, so FDR, which for us is x in our case. Now for us is d in our case. Alright, I'm going to write fdx, then fx, and just sub for d, I think. Okay. Okay, we know the work from what we had here. So that's negative jvx over 2d equals force. And that's it, actually, because we already solved for force. Any questions on D? I'm going to take that as a no. So then part E. This time the block is not clamped to the table. So the block is fired into the wood, or projectile is fired into the wood. Um, it still travels a distance d into the block, but the block also travels a distance d on the table. Um, yeah, so they're gonna collide. It's eventually gonna stick into it, but there is a point where the projectile is still moving inside the block, even as the block is sliding on the table. Okay, so let's start with energy. What's happening with our energy? Okay, we've got kinetic energy from the projectile. So that's our initial kinetic. Then what's opposing it? Because eventually everything stops. Okay, I've got friction. Um, so the work of friction from the block on the table. And then we've also got the work of the block on the projectile. Okay, so that's kinetic energy minus the force we got earlier times the distance. Oh, I've actually subscripted this differently. I need to go back. That force is FB. FB, 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 FB. I can leave that one as general, but... And then this is D... just D. Okay, this is a subscript DN. Because now it's the distance when we're not clamped. And they subscripted that for us here. DN, FB. Okay, so I'm just matching their subscripts. So I didn't do that the first time. Minus the work of the friction. What's the work of friction? Okay, so they subscripted for us again. Average force of friction between the block and the table is Ft. So I'm going to throw that up. Ft. Times what? Times the distance. Which distance? Dn or capital D? Capital D, because that one's... just reverse these down here. So I'm going to reverse these up here, but... Block, friction. So my work of the block on the projectile is the force of the block for the distance that the projectile travels inside the block. And my force of friction from the block on the table, or work of friction from the block on the table, is the force of friction on the block on the table times the distance that we traveled on the table. Okay, now we can substitute. So my kinetic energy we said earlier would be the distance that I would have traveled into the block if it wasn't moving, times the force of the block acting on the object. Okay, minus the force of the block if we are moving, minus the force of friction on the table. So then we could solve for FBDN. So FBDN equals FB d minus FTD. Okay, so that we were still using all the terms that we need to use. And then solve for dn. Oops, FBD. Okay, that was a little bit weird for the way I did kinetic energy there. The only reason I did that was because they asked us to use these specific terms. So I was looking for a way to rewrite that kinetic energy using only FB and Ds. And the only reason why I could sub for that directly is because we'd already found it in the previous problem. Okay, any questions on E? So you mean you understand what's going on, but you're not sure you'd be able to do it on your own? Gotcha. Which part? Because you seem to have the setup right. So those distance were subscripted for us. So we've got a distance d that we used from the previous equation. And since our kinetic energy of the projectile hasn't changed from part d to part e for our initial kinetic energy, we can still reuse any formulas we used for the previous one. I've got a capital D, which is my distance across the table. So block slides across the table, distance d. And then dn is how far we traveled into the block. Okay, so I'm going to keep going with F. Okay, for F, we're getting a new expression. Still dn in terms of d, the mass of the projectile and the mass of the block, though. So we're rewriting this. Okay, if I want masses, I'm probably going to use momentum for this. So what's my momentum equation? Okay, mvx equals... Okay, cool. So I'm going to solve for v. Okay. Then we can go to energy. Since the energy of the system immediately after the collision should be equal to the work due to friction in stopping it. So that's 1/2 mass plus mass, so of the projectile and the block, times our new v squared. Should be equal to the force due to friction times the distance on the table. And then we can sub in. So this is 1/2 m plus capital M times mv x over m plus m squared. Okay, so one of these m plus m's will cancel, and I'll be left with m squared vx squared over 2 times m plus capital M. Okay, then I need an equation that I can sub for VTD, because I can't have an FT in there. And I can't have a D in there for what they want us to do. So I'm going to go back and see if we can use this. Okay, that'll give us an... If I resolve this one for part F, then I could say FTD from this step is equal to FBD minus FBDN. Capital F. Wait. FBD minus FBDN, yeah, okay. Okay, so I need to get rid of this FB. So I'm going to try to rewrite this so that I can get an FB in there. Okay, going back. FB is equal to this. FBD is my work, which is my kinetic energy, which is 1/2 mv squared. So if I can rewrite this to get 1/2 mv squared, we should be okay, which I can do. So this will be if I pull out the 1/2 mvx squared to get an FB on this side, I'll be left with an extra m over m plus capital M. Okay, then we can cancel. This is FB, this is FB, this is FB. So that leaves us with m over m plus m equals d minus dn. Okay, now I've got all the terms that I need. I just need to solve for dn, and then we're done. So dn equals d minus m over m plus capital M. And we've got our expression in terms of everything we need. Any questions on what we did? Okay, so I believe for this year, that last part was considered really hard, and they ended up giving the point not for the final answer, but for one of the steps before that. Um, so I think as long as you got to this step where you had substituted for V, they gave you full credit. So that one was a little bit hard. Um, the other two for this year, though, I don't think are that rough. Um, so we'll be doing the other two this weekend for homework. And then I'll come back on Tuesday to see you again for physics and Monday for Calc BC. I did forget to post the videos for Calculus BC to the WeChat, so I'm going to post that when I post the video for physics. So you'll see a bunch of links at once. Okay, we're a little bit over time, and I gotta prep for the next class really quick and get the see if I can get Skype working again. So I will see you next week. Goodbye.